Pleasant day to everyone. Today we are going to discuss Module 6 of CE 3151. And in this lecture, we are going to discuss an overview of curve fitting and interpolation. So curve fitting is a process of constructing a curve or a mathematical function that has the best fit to a series of data points subject to constraints. In curve fitting, it finds an appropriate mathematical model that expresses the relationship between a dependent variable, y, and an independent variable, x. So the curve fitting is also defined as a process of finding the equation that would best fit, or a curve that would best fit and is most suitable for predicting unknown values or variables. We estimate in curve fitting the values of the parameters using non-linear regression. So to have a better view or understanding of curve fitting, let us take into consideration the given table. We have here different values for variables x and y, in which we define now or denote variable x as our independent variable, which is defined as a variable that is changed or controlled in an environment or in an experiment, while variable y will be our dependent variables, which are values that would depend on our independent variable. So if we are going to graph now the given values for variables x and y, and we plot the different points on this graph, we could observe that the points on our graph would not normally form a straight line. So in this case, in order to find now the best line that would define the relationship between variables x and y, we try to draw a line that would in between our points. And this line now is defined by our slope equation, an equation of a line by its slope, which is y equal to mx plus b, wherein m is the slope of the line and b is our y-intercept. So this equation now of a line in terms of the slope will be our model for our equation in numerical solutions, in which we have now this equation transformed as f of x, or the function of x, which is y, is equal now to ax plus b. While in statistics, this equation would also be transformed in terms of the values of beta, wherein fx now is equal to beta sub o plus beta sub 1 times x. Comparing now the locations of the points from the gathered data for variables x and y, and the best line that could define, or the best equation that could define the relationship of variables x and y, we could see that there are some discrepancies. So in this graph, we have now our points as our exact values, while for the points along our fit or equation for the best fitting curve would be what we call our approximate values. So the difference between the exact and approximate value would be what we call your epsilon, or the error, wherein this value now will be added to that equation of f of x equal to ax plus b. For the measurement of the error or the epsilon, which should be as much as possible minimized in our curve fitting, two methods or general methods are followed. The first one is what we call the maximum error, and the second one is the root mean square or RMS. In maximum error, we take note of the equation E sub infinity of f is equal now to the maximum value of the absolute difference of the function of x sub k minus y sub k, wherein k is greater than 1 but less than n. So take note, for this equation, E sub infinity of f is our maximum error, and the function of x sub k is the approximate value, and y sub k is the true value of the point. While for root mean square, it will now be given by the equation E sub 2 of the function f is equal to the square root of 1 over n multiplied to the summation of the quantity function of x sub k minus y sub k squared. So there are four general standard methods that we follow in curve fitting. The first one is graphical method. The second one is the method of grouped averages. Third is the method of moments. And fourth is the method of least square. So for the different methods in curve fitting, we are going to discuss this in our next lectures. So that's it for the overview of curve fitting and interpolation. Thank you for listening.